The directions state to multiply. For example A, the problem reads 2x, open parentheses, 6x plus 3, close parentheses. In other words, we have a monomial times a binomial. However, this does look familiar. This is the distributive property. We must distribute the value immediately in front of the parentheses to each term inside. So for us, that means 2x times 6x, and then 2x times 3. Now that we have distributed the 2x, we need to simplify each term. The first term consists of 2x times 6x. Because that term is glued together by multiplication, we can use the commutative property and multiply our categories, our 2 times 6 and our x times x. And when we do that, we get a value of 12x squared. The second term is made up of 2x times 3. Again, a term is glued together by multiplication, so we can reorder it or multiply our categories. In other words, 2 times 3 is 6, and we still have that x, so the second term simplifies to 6x. Our result of multiplication is 12x squared plus 6x. Looking at example A, again, this time we are going to view the problem in a more visual way. So starting with the expression of 2x, 2x is a monomial, so that means we are going to be looking at a single row. So I'm going to draw a rectangle that's one row across, and it is multiplying a binomial of 6x plus 3. Because a binomial is made up of two pieces, that means that one row is going to have two columns. Now, what we're going to do is we're looking at the area of these different regions. One area is made up of the dimensions of 2x on one side and 6x on the other, while the second rectangular square has the dimensions of a 2x by a 3. And if you recall, how to find the area of a rectangle is length times width. So looking at the first rectangle, its dimensions are 2x by 6x. Well, we multiply. What is 2 times 6? 12. What is x times x? X squared. So the area for that region is 12x squared. The corresponding or adjacent rectangle has the dimensions of 2x by 3. And again, we want to find the area of that region. So we multiply. 2 times 3 is 6, and it's a positive 6. And then we only have an x, so the x remains. And if you notice, the values inside our rectangle, the areas we found, is the exact same value that we found when we distributed the value. So this is known as the box method, or a visual representation. Example B reads 4x, open parentheses, 5x squared minus 2x plus 3, close parentheses. Technically, this is a monomial times a trinomial. However, it simply looks like distributive property, and that is what we are going to do. The 4x needs to be distributed to each term inside the parentheses. So let's begin. 4x times 5x squared, 4x times negative 2x, and 4x times 3. Now we still have 3 terms, but we need to simplify each of them. Looking at the first term, we have 4x times 5x squared. That can simplify to 20x cubed. The middle term, made up of 4x times negative 2x, simplifies to negative 8x squared. And our last term, made up of 4x times 3, simplifies to 12x, making our answer 20x cubed minus 8x squared plus 12x. As I did the previous problem, we are going to approach this problem using the visual way, the visual method, starting with our monomial being a 4x That means we are going to be dealing with one row. So I'm going to draw a rectangle, one row wide, and labeled with 4x along the left side. This 4x is multiplying a trinomial, specifically 5x squared minus 2x plus 3, written across the row. Now, because it's a trinomial, that means I am going to have 3 columns in this one row. Like before, our goal is to find the area of each of these regions based on their dimensions. Starting on the left, where we have it labeled 4x on the left side and 5x squared above it, we need to find the area. Again, area is length times width. So looking at our coefficients, 4 times 5 is 20. Now x times x squared gives us x cubed. We have now found the area of the first square. Let's turn our attention to the middle section. Its dimensions are 4x along the left side, but negative 2x across the top of it. Well, again, the area is multiplying length times width. So let's multiply our coefficients. 4 times negative 2 is negative 8. X times x is x squared. Our third final rectangular area is made up of the dimensions of 4x on the left side and 3 across the top. Again, the area is where we multiply these two values. 4 times 3 is 12, and we have an x. And so in these three regions, we have 20x cubed minus 8x squared plus 12x. And if you notice, these are the same values we came to the conclusion of when we distributed.